All right, so in the next one, we have information about the length. So again, a diameter and a radius, we'll have to fix one of those. But now we're going to extend this to also look at force. So input force, output force. Our formula actually comes from one that's similar to what we had for torque. I even mentioned, I think, when we were dealing with torque in the other section, sometimes it was L for leverage, L for length, but we can look at this as an input length times an input force basically makes a certain amount of torque. And then that torque is going to be preserved as long as we don't have some issue with the setup. So think of something like a lever starts to bend or flex, then you run into problems. But as long as everything is steady and works properly, then this full amount should be transferred to the output of the system. And the output of the system is going to have a very similar setup, output length times output force. Now, technically here, we don't ever find the mechanical advantage. That would be built into these ratios and solving back around. But we're just not told to find that, so we don't worry about it. The length, again, can be any length measurement, anything centimeters, meters, inches, feet, technically, as long as it matches and as long as it's a fair measurement. So, like before, we can't use a centimeter, or rather, we can't use a radius compared to a diameter. It has to be the same for both. So, we'll want to make that adjustment before we go any further. Notice here, this one's diameter, other one's radius. So, we don't like that. If we go ahead and double this one up, then we get the diameter is that'll be 2.28. Okay, then we have to figure out which one's input and which one's output, and sometimes it's a little bit tricky if you're not fully familiar with setups. But when we say hatch wheel, think about if you've seen in the movies where they're in the submarine or the giant ships and they're using the cranking down the wheel to lock the door. I want to think of something like that. So this is the larger number here is where you would put hands in order to put in force and try to make it turn. And then the axle in the middle, like before, ends up being for the output. So this number is going to be our output length. Okay, find the force required. So I'm trying to figure out how much effort I'm putting in, and I don't know what that is right now. So that means I'm looking for Fi. And the force that we put out, again, output force, that's the number we have. So yeah, a little bit of planning here, but once we sort of get our numbers going, see what's going to plug in, then it should be relatively easy to finish working down and get a solution. So let's try it. All right, input length, what do we have? We've got 29.15 centimeters. Input force, we don't know what that is, but we want to, so that seems okay. All right, then output length, that was that 2.28. And then output force, 389.42. Checking through our units, the centimeters and centimeters would cancel. That's also why it wouldn't be super important to convert to meters, because even if we did, that conversion itself would cancel. All right, so from here, trying to get that force so we can divide by 29.15. Notice that newtons are the only things left over. That's going to be on the answer, so we're good to go. You can do this a couple of different ways. Like we talked about on another question, a lot of times students are hung up on simplifying first. Here, this is actually easier and fewer buttons to press on the calculator. If you just do 2.28 times 389.42 and then just keep going in the same set of commands and divide by 29.15. So I don't know what you get from multiplying the top purple numbers together. It doesn't matter. I don't care. I'm never going to see it. I've never seen it. Um, all we need to do is just get the final answer. And so from running that through, we get 30.46. and newtons because that was left over from before.